All right. So, uh, what we're going to be learning about today is solutions. Okay. And so, uh, does anybody know the definition of a solution? Can anybody tell me that?
Isn't it a mixture of solvent and
What, Ethan?
a mixture of a solvent and a solute?
So, a mixture of a solvent. Yeah. So, basically, the best answer that you can look for is a solution is and I guess I should probably put this down, a mixture. Okay, we'll talk about a mixture first. A mixture is any two, I don't want to say ingredients, two compounds mixed together. Okay, so a mixture could be things like dirt and water, or M&Ms and Skittles. Okay, you can mix any two things together. That's a mixture. All right. The big difference between a mixture and a solution is when you have a solution is two or more compounds combined together in a homogeneous mixture. Okay, homogeneous means you cannot see the difference between the two particles, okay, or substances, right? So if you have, let's just talk about if you mix dirt into water, can you tell the difference between what stuff in there is dirt and what stuff in there is water, especially after it's settled? Yeah, you can. Yeah, you can. You can see that. And so that would be a heterogeneous mixture, but a homogeneous mixture, this is going to be where things actually kind of dissolve or mix into one another. So like when you take water and salt, all right, you're dissolving the water in or dissolving the salt into the water, and you cannot, like, once you've mixed it in, you can't see which parts of that solution are salt and which parts are water. Okay, it is homogeneous. Okay, and that's what makes it a solution. Okay, so solutions have two parts. So parts of a solution. Okay, there is your solute and your solvent. Okay, does anybody know what the solute is?
It's what's being dissolved in
Yeah, okay, so essentially the solute is the compound that is being mixed in or dissolved into a solution. Okay, and you don't always want to think of solutes as things that dissolve, because solutes can be liquids. Okay, we like to think of solutes all the time as like sugar or salt or things that you mix into like liquids that dissolve into them. But solutes can be liquid things as well. All right, but they're the one that is being mixed in or dissolved into a solvent. Okay, and the solvent. Okay, solvent is the compound that dissolves or takes in, essentially, the solute. Okay, pretty much anytime if you're reading a problem or seeing anything like this, if you see water is pretty much always, I don't want to say always, but I think pretty much always is generally always a solvent. Okay, I can't even think of any off the top of my head where water wouldn't be a solvent. Okay, but I do know that I don't know. I'm sure there are probably some cases where water isn't. It's maybe a solute, but water is generally pretty much always going to be a solvent, and it's the most common solvent that we'll use in anything. Okay. And so what we're going to be looking at today is concentration. Okay, and concentration is just going to be essentially a measure of how much solute is in a specific amount of solution or solvent. Okay, because sometimes you're looking at the total mass of the solution, and sometimes you're just looking at the mass of the solution versus the mass of the solvent, or sometimes it's moles of solution to moles of solvent. But anyway, so we're going to be looking at a few different concentration ratios, okay? Does anybody need a second, or can I clear this page?
A second.
Yep, no problem. Let me know when you're good. I'll give you like, I don't know, I'll give you like 2 minutes. It's not like we got to rush through anything. Anthony, I got your things, by the way.
I've just been having trouble like sending pictures of things. I don't know why.
Yeah, no, it's all good. Trust me, as long as, and your guys' class has been the best in terms of, you know, getting attendance at these Zoom meetings and then also getting work in. So I'm not stressed out. You know, if you're having trouble and you can't get it to me, right, you know, as long as I get it, it's fine. There are other classes where my kids are not getting things in that really stressing me out right now. But you guys have been really good about that, so I'm not too worried about it.
I got it.
Okay. All right. So I'm going to go ahead and clear this unless anybody says don't do that. And I'm going to do that. 3, 2, 1. Okay. So we're going to be looking at concentration ratios. Okay. And there are going to be 4 primary ones that we're going to be looking at. There's a 5th one, but honestly, in all the college chemistry classes, I can't even remember really using those. That one. There's these 4 ones that we're going to go over are the primary ones. Okay, and they're also the ones that make sense. All right, and so what we're going to be looking at is the first one we'll look at is percent by mass. Okay, so percent by mass, we're essentially going to be looking at how much of a total solute, or how much of, the total mass of a solution is a solute, okay? And so what we'll do for that when you're doing for percent by mass, okay, this is just going to be the mass. I'm going to see if I can extend this over just a little bit. Okay, so the mass of solute divided by the mass of solution. Okay, so we're looking at the whole mass of the solution, and then that times 100. Okay, because when you're doing percent problems, you always want to multiply by 100. All right, and so we'll just do a practice problem real fast with this stuff. So when we're doing percent by mass, so say we have a mass of 3.6 grams of NaCl. Okay, so we have that, and then we also have a mass of 100 grams of water, H2O. Okay, so now remember, this is our mass of our solute with the salt, and then the mass of our solvent with the water. But when we look up here, it's the mass of solute divided by mass of solution. Okay, so solution mass is going to be equal to these two things added together. So it's just going to be 103.6 grams of solution. Okay, and so all you're going to do to figure out what percent of this is salt, okay, you're going to take 3.6 divided by 103.6, all right, and that comes out to be, well, it comes out to be a lot of things, but it's going to be, when you look at it, we're only going to focus on this 3.6, so going out 2 sig figs, so have 0.035. Okay, now we multiply that by 100, okay, and you're going to get that this is 3.5% NaCl by mass. Okay, so by mass, that would be 3.5% salt. All right, does anybody have any questions about that?
No.
All right. No, but I mean, again, that's kind of, these ones should be easier. Just kind of going over that stuff. All right, and so are we good here, or do I need to leave this up? All right, I'm going to go ahead and get rid of it then. So another concentration ratio we will look at is percent by volume. Okay, so this is going to be very, very similar. This is just going to be the volume of solute divided by volume of solution, and then that times 100. Okay, and so remember when I talked about that solutes can be liquid occasionally, especially if you've already mixed two things, you know, like in the lab, if we have two aqueous solutions, that's generally going to be when you're making this sort of stuff, or if you want to dilute like ethanol, like if you had straight ethanol and you wanted to make it weaker by adding water, you would just go through and do something like this. And so I'm going to use an example. If we had 35 milliliters of ethanol, okay, and we also had 155 milliliters of water, okay, what percent of this is ethanol by volume? And so you would need to do 35 plus 155, which is going to be 190. So mass of, or not mass, volume of solution is going to equal 190 milliliters. Okay, and then all you're going to do is take 35 divided by 190 times 100. Okay, and that is going to equal 18% ethanol by volume. Okay. Okay, are there any questions about either these percent by volume or percent by mass ones?
We're
Okay.
so talkative, but I don't think so.
Yeah, I assume not. Again, these are relatively simple, but I did want to just check on some of these. All right. Got about 10 minutes. Let's go ahead and leave off here for the day, okay? We'll pick back up on Thursday, and we're going to go over. We already have talked kind of about how you do molarity one way. We're going to talk about that way and another way you do molarity. And then we're going to also talk about how to do dilutions, all right? And so I am going to stop sharing. You guys do not have